consultant. I have been into automation as well with multiple shell scripting, Python, Terraform, Ansible, right? And I'm a Kubernetes expert. On the cloud credentials, I am certified, professionally certified with all the three major cloud service providers, AWS, Azure, and GCP. So yeah, that's a background about me. On my hobbies, I love to travel and share my knowledge. That's where we are here. So that's a brief background about me, folks. Let me understand about my audience here. I believe you can correct me. You can use the chat option. I believe folks here in this forum right now, mostly they are from performance engineer testing background. Folks, are you guys on that domain? You can what you could do, everybody, use the chat option, and if you could briefly touch base upon your primary skill, performance testing, engineering or automation engineer, or a support engineer, or an SRE consultant, or a DevOps engineer, and how many years of experience. So if you could briefly just your core skill set, comma, years experience, if you could mention in the chat, I would understand about you quickly. Can everybody do that, please? Okay, Nagraj is SDET architect. Okay, I see Shrest test automation engineer, 4 years experience. Sudhir working as a SRE with 5 years. Prasanna, 15 years as a manager. Network engineer, Sudarshan. Vignesh, 10 years into performance testing, technical lead. Okay, good to know about you guys. Santosh, SRE, 1 year, and performance testing, 6 years. Good to know about you, Santosh. Come on, guys. Let's introduce yourself on the remaining. Uh, Multiple roles. I see Prasanna has played multiple roles: Scrum Masters, testing, QA, ETL, and business intelligence, niche skills. Okay, good to know about you, Prasanna. Verification and validation engineer, 4 years experience, Thiruvardhan. Okay. Performance test engineer manager with 16 years experience, Raj Thakur. Technical architect and DevOps engineer. Okay, good. AWS engineer. Okay. So I see most of you are from either you are from automation or you're from performance, you are into cloud, right? So I see various experience here. Good to know about you, friends. Okay, we have one fresher also joining here, final year student. Okay, good to know about you. How do you pronounce your name? Kikilomo. I hope I pronounce your name correctly. Forgive me if not. Okay, good to know. Perfect. Thank you so much, everybody. Okay, let's get started. So we today is the demo session. So I'm going to talk about one of the courses that I am coming up with Isha. I'm going to talk about the course definitely and how we will go about it, different contents of the course, and how we'll take it, the topics, right? How you'll be benefited. You can ask your questions, queries, right? We will take all those things, right? So that's the main agenda for today's discussion, friends. Okay. So we will, so that's a brief about me. I have already given you a brief. So this is the agenda for today's discussion. So we will start with a question. Okay. I would like you to answer to that question. Okay. That's a very important question, which I'm going to ask you today in the first slide. And then we're gonna go over software development and deployment evolution, how the journey has been or in IT of IT, how the software has been developed and deployed over the years. From 1980s, we are into IT. Humans are into IT field, IT technology, and we have been making progress, right? So we'll understand that today, how the journey has been, and then we'll talk about the course, and then you'll have a clear-cut understanding about the course, and I'll make sure that you will have some learning today, right? Let's do that. Fine. Let's start with the questions. Okay, I'm gonna ask this question not just for the performance engineers. I would say anybody in IT. Okay, I'm gonna just assume that I have mentioned that our performance engineers expected to know this. This question is now relevant to anybody in IT. Okay, that has been, this is like some 6-7 years back. I put this slide and I continue to do that. It's very important slide. So now let's answer this question, friends. Anybody who is into IT, do you think they're expected to know this? Either you are into cloud operations, you are into performance testing, you are into automation testing, you are into performance engineer, you are into SRE or a cloud engineer or a DevOps role, whatever skill that you are into. Do you think these skills are important for you? I would like everybody to respond yes or no idea. Please use the three options, friends. Yes, no, and no idea. DevOps, microservices, containers, and cloud. Do we think these things are important to know, friends? Okay, I am seeing the responses and it's everybody saying yes. Okay, Sudhir, Raj Thakur, Prasanna, Vignesh, Dilisha, Shaw, Kalmine, Ahmed, Kilomo, Thiruvardhan, right? Rajiv, everybody, right? No doubt about it, right? These topics are the most important things. Why? Okay, let's understand this question. Why? Why I have put these four things? Why not other things? Why I have not put other things? Why these four things? DevOps, microservices, containers, and cloud. Why these things specifically I have put this? You will understand, you will get the answer in the next slide, friends. Here is why these things are important. Okay, when you go over the software development and deployment evolution journey, you will understand that the phase that we are in right now, we are into this phase of the software progress, right? Earlier, if you talk about the deployment process, if you talk about the deployment process, we started with waterfall, we moved to agile. I'll talk about that briefly. What is that? Now we are into DevOps. I have put the timeline here, years range here. We are into DevOps right now. We have made progress over the years. We started with waterfall. We understood why we should not stick to waterfall. We moved to agile, and then we have progressed to DevOps. Coming to the application architecture, how the application has been architected. We're working on monolithic applications when we started our IT journey back in 1980s. We moved to 3-tier architecture. Now we're into microservices. Everybody is talking about microservices. We are very few people, very few companies are talking about monolithic applications, 3-tier applications. It's all microservices based. And where do we deploy microservices, friends? Few of you would know this. Where do we deploy microservices? We deploy the microservices on the containers. If you don't know, no problem, friends. That has been the journey. So we were deploying the monolithic application on the physical servers. Then came the virtualization phase, where we created VMs, where we created virtual machines. We were deploying things on a VM. Why VM? What was the use of virtualization? What was the benefit? What was the goal? We'll understand that. And now we are talking about containers nowadays, friends. We are deploying our microservices applications on containers. We were deploying our 3-tier, N-tier application on the VMs. Now we're talking about containers. And now where is the infrastructure? Either you can start with your own data center, like how Amazon did to host Amazon.com, or big players. Not everybody can afford to have a data center, friends. And now we're talking about cloud. Everybody is talking about cloud. We have so many startups. How it is possible to have so many startups? Because it's not a burden now that everybody has to create a data center. We have some offerings like cloud. Anybody, if you have few developers, QA engineers, deployment engineers, we can start a company and we can deploy the application in the cloud and we can use the cloud resources. So this is the phase we are in right now. DevOps, microservices, containers, and cloud. Whichever technology you are into cloud operations, you need this. You are into automation engineer. You may not need a tech stack for automation engineer, right? If you're into automation, you are mostly into the functional testing, automation, right? Those things. But if you love technology, this is the situation we are in right now. This is where we are making progress here. If you're into performance testing engineering, no doubt you have to know this. If you're into DevOps engineer, SRE engineers, you have to know this. There's no other go. If you are a developer, you need to know this, because the way you deploy microservices, the way you develop microservices, the way you deploy microservices is different. So let's understand this slide, friends. So I hope everybody understood why DevOps, microservices, containers, and cloud are important, and where is it in the journey or the cloud of the software development and deployment, right? In the evolution, we are in this phase, and that's why it is important. Now, let's understand one by one DevOps. Why we're talking about DevOps, friends? Why DevOps? So to understand, you need to understand the situation, what was before. Then you will be able to appreciate why we're talking about DevOps and what exactly it is, what problem it solves, what it aims at. Everybody talks about DevOps, but what exactly it is. So in the waterfall, when the software development started, friends, it was started with waterfall model. Think about it. I'm going to give you, let's say, I'm going to, let me open a notepad. Let me write few things so that you understand better. We'll go a little basics today, okay? And then we'll talk about the course. It's very good to start with the basics. You need to ask questions, right? So let's start with SDLC. Everybody understands what is SDLC, friends? The full form? Folks in IT? Everybody understand this full form? Can anybody let us know the full form of SDLC?
Software development life cycle.
Uh, Software development lifecycle. Thank you. Guys, please be on mute. Somebody is echoing. Thank you. Software development lifecycle. Okay, what exactly it is? Software development lifecycle. What exactly it is? The way we go about developing a software. It's software development lifecycle. Think about it. Let's say today you have a business idea. See,
This
every
conference
software
will now be
development
recorded.
starts with a problem statement. You want to solve a problem. You want to solve a problem. Every software development has started with a problem. Somebody wants to solve a problem. It could be problem of banking, the way people earlier, right? If you go 20 years back, 25 years back, the situation in the bank, friends, people were maintaining physical registers. Okay, if somebody is depositing the amount, has come to open the account, there was a physical register, physical copy, okay, notebook, and then your page would open and you'd be written, okay, this person has deposited this amount on this date. This was the situation, right? This is how it has been earlier.
Analysis.
If you want to
Develop
book a train ticket, you have to go to the railway station and be in the queue to book the railway ticket. There was no other go. If you want to book a flight ticket, you have to go to the airport and book the flight ticket. There was no other option of online ticket booking that we have right now. So the solution that you see right now, all the net banking applications, or we have in India, we have IRCTC to, if you want to book a railway ticket, train ticket, or if you have so many flight applications, flight booking applications nowadays, that you can simply log in and you can be at home and you can book the ticket. So
thing.
every
And
solution,
second
every
one,
that you see
there is
right now
a
starts with the problem statement. We talk about your cab booking, right? Uber, Ola. There was nothing of that sort. when though these applications were not there, they solve a problem. Every solution starts with a problem statement. And then let's say, and then let's say today I have got some idea, the question, problem statement. Now, let's say somebody is not a technical person. Let's take this example of Make My Trip. Let's take this example of Make My Trip. I hope everybody understands Make My Trip. It's a just a ticket, online ticket booking application website. It's a website, makemytrip.com. I hope you guys are aware of this. Everybody uh, from different countries. I know from India, people from India would be knowing this. If you are across the globe, you must be having a similar kind of application in your country, right? Which you would be using to book your flight tickets or any train tickets, right? So this is a popular website, similar online ticket booking application. So think about this application. So there was a problem. We were dealing with a problem, right? We didn't have this a unified way of display where anybody can go and book the flight tickets, train tickets. So Deep Kalra is the owner. Okay, if you Google it, friends, you would find that the owner of Make My Trip is Deep Kalra, the name of the person who is behind the mastermind behind this application. We had separate flight carrier tickets, let's say Indigo or Air India, Air Asia, right? We had different Kingfisher, we had different separate online portal. But there was nothing like a unified where any website which would give you the unified way of displaying things, online ticket booking. So this was the problem statement we had. So let's say Deep Kalra is not a technical person. He would have approached some company like TCS, Infosys, Wipro, right? And what would have happened, friends? Requirement gathering phase, right? So every software solution starts the problem statement. And then the second would be the requirements gathering phase. So let's say he would have approached, I don't know, maybe wrong. Let's say TCS or Infosys, right? Any company, okay? So requirement gathering phase, friends. People at company side, they would be trying to understand what is the vision of Deep Kalra, what he wants to do. So Deep Kalra would have explained, I want user to register a website where user could come, register, right? Can do a search for source and destination with the date option. And the person should be able to get all the details of different flight carriers, not just one, but different flight carriers, right? So multiple requirements. And then obviously the, the software would be in the planning phase and the code plan and design phase, right? It will be design, architecture and all. And then the coding would start, right? And the coding phase would start. And once when the code is done, obviously we need to build the code, and deploy to the QA environment, right? Then deploy the code to a QA environment. And then all the functional testing, performance testing would take place, right, friends? So this is nothing but the SDLC, the way you go about developing a software. Very simple. Just think rationally, you'll be able to understand every step, right? Then after deploying to QA environment, we'll do functional testing. Then we would do performance testing. Then we can do security testing. Well, these things are important. We can do UAT testing. And once everything is validated, we would be ready to deploy my code to production. Yes or no, friends? And then obviously when we deploy the code to production, we need to do the maintenance and support and all those things, right? We want to keep our users happy. Like if when you use a website, Amazon, Flipkart.com, I don't want my website to crash. If there is a lag, performance issue, I want to get it resolved, right? So there would be engineers sitting in the company side would be looking into the metrics, right? SRE engineers, ops engineers. So a lot of different people would be involved in the any company for the best experience of the users. So this is nothing but the SDLC. Guys, are we on the same page? Everybody? Yes? Please give me yes in the chat. All on the same page? This is SDLC. Normal. The way we go about developing a software development life cycle. Okay, now what is this approach of waterfall? See, this is one of the approach we have taken. What did we do in waterfall, friends? We developed all the feature at once. We developed all the features, whatever, let's say Deep Kalra would have come, right? I'm just giving one example. Whatever the software was planned to develop, we developed the entire feature at once. We took 8 months to 1 year to 2 years, and we developed all the features. Then once all the features are developed, we started to test the code, test the application, full-fledged application. Can anybody highlight the problem with this approach? When the entire development completes, entire full-fledged application, whatever was in the planning phase, whatever was planned, when everything was developed, the application was started, we started to test the application. Yeah, people are telling cannot go reverse back, it takes time, cost consuming. Guys, you're not answering the fundamental thing. Okay, now I'm going to tell you in the waterfall model, what is the basic approach? What is the basic problem? Let's say there is scalability issue, some architectural flaw. The application is not scaling up. The application is not scaling up. It is crashing with more users. Now, what would you do in such situation? You have spent 1 to 2 years in developing the entire features, and after 2 years, we're coming to know that application is not scalable. What anybody can do in this situation? Is it easy to go back and change the architecture and redesign the code? Is it easy? Is it simple or expensive? Time consuming, wastage of time, resources, everything. There were a lot of problems with waterfall, friends. We cannot have such an approach. So we learned from our mistakes. It was the first thing. That's where we started. We humans, that's how we started. Right? We progress, right? We learn from our mistakes and we learn and then we progress. Yes, we have progressed and we moved to agile. And what did we do in agile, friends? We split the development into multiple phases. You might be hearing this word in your company, sprint. This sprint, this feature, this sprint. So we developed the entire software, whatever was there, we split into various sprints, phases. We call it phases. And we did SDLC in each phase. We will develop few features. We will develop only register, login, and we'll test it thoroughly. We'll do functional testing, performance testing, security testing, UAT testing. We will test it thoroughly. We will show this to our customer client. Boss, are we going on the right track? Do you have any feedback? So let's say Deep Kalra would give some feedback. Okay, no, I want you to do this. So when Deep Kalra sees something, he would be having some feedback. We incorporate the feedback and we again build the next phase. We developed more features. Again, we went to the Deep Kalra. We got the feedback. We did all the SDLC. And that's how we progressed. So in this agile, friends, do you think at the end product, we would be getting what the customer is expecting? It will never be a surprise at the end. Yes or no, friends? Yes or no? In the agile process, do you all understand this? Much better, much in line with the customer expectation, because every feature we took the feedback, customer feedback. We did SDLC for each sprint. Much better. So that's what we do in agile. A lot of companies are into agile and nothing wrong. It's perfectly fine as a process. Then why we're talking about DevOps? See, think about it. Okay, I'm gonna ask this question. Let's say when the code is ready, what is the ultimate thing that you want, friends? When the code is ready, what do you want? Ultimate thing. Okay, don't tell me I want to build the code, deploy to QA environment. What is the ultimate thing? I want to deploy my code to production. Yes or no? When the code is ready, deploy to production, but we cannot take a risk. of quality validations, right? So we do all the quality validations, okay? If this process 5, 6, 7, 8, 9, 10 is done manually, friends, it takes months. Manual testing, again, develop testers will raise bug, developers will fix it. Again, manual testing, right? Then performance testing, security testing. This process can take months. So what we should do, we need to automate this. Automate to the best possible extent, at least the regression part. New features, fine. We could write test cases, we could do manual testing, but at least the regression part should be automated. Yes or no? Why? Because I don't want to wait longer. Nobody wants to wait longer when the code is ready. Nobody wants to wait longer to deploy the code to production. Yes. We don't want to take a risk without quality validations. We don't want to deploy the code to production, but we don't want to wait longer. Nobody, no company. Think as the owner of the company. Would you like to wait longer, friends, if you're the owner of the company? Don't you think you would make progress? You do attempts to make this process better? Nagraj, just hold on. Just Nagraj, hold on. We are going there. Today is just a demo session, Nagraj. Just hold on. Friends, are we on the same track? Do we think that we need to automate this process, friends? Do you think we need to automate this process? And that's what DevOps does, friends. And that's what DevOps does. And that's what DevOps does. So that's how we are making progress, okay, over the years, waterfall to agile to DevOps. And DevOps does nothing. As a process, we are still agile. Only thing that we are bringing is automation. That's what DevOps does. DevOps is all about bringing automation to the same agile process wherever possible to the maximum extent. Why? What is the main reason? I want to increase the release velocity. I want to make frequent deployments. We want to do frequent deployments. That's what DevOps aims at, right? That's the first thing, guys. Now, coming to the monolithic applications. Okay, this is one part. Okay, let's spend some time on this slide. You'll understand about the course better. Okay, hold on. I would request everybody, if you know this, I know I'm talking about basics, right? But this is very important. Those who think they know it, guys, bear with me. The course today is the demo session. I'm going to talk about the course. Okay, there are no technical things that I'm going to start. Okay, so understand the expectations, right, Nagraj, for you. Understand the expectation for today's session. We are not going to talk about technical things today. I'm going to talk about the course, and then we're just talking about the basic stuff here, right? Let's be on the same page, friends. Now, coming to this application architecture. What is monolithic? Do we know, friends, what is monolithic applications and what is the difference between microservices? Yes or no? Please use yes or no in the chat. Do we know the difference? Feel free, friends. With me, feel free. Yes or no, doesn't matter. I'm here to tell you about everything. Okay, no problem. Now, monolithic application. Okay, I'm gonna save some time. I have a diagram, friends. Okay, let me just open one of the diagrams. Okay, let quickly one of my GitHub things. I'm gonna talk about. Let me, friends. I'm gonna directly show you diagram, and it'll make life easier for everybody. Let me just give me a minute. Okay, friends, look at this. When we say monolithic applications, friends, the diagram that I'm showing you here is a 3-tier application. Okay. Web server, which is serving my web requests, my web pages. Then we have the application server, which is where the logic is there. And then we have the database, 3-tier application. Focus on the application server. What do we have in the application server, friends? We have modules, the code, the functions. We write the functions. I request everybody to be on mute. If you have any questions, you can ask me. Request everybody to be on mute. Thank you. Now focus this 3-tier application. Normal web server, app server, database server. Focus on the application server. These are nothing but the features. Modules are nothing but the features, different features. Think about flipkart.com, and let's say you have features for different, you have different items, right? Electronics items, clothing, different features, right? Payment module, inventory module. We have a lot of features, right? Because this is a complete e-commerce application. So think about these are my features: M1, M2, M3, M4 modules. What you're going to find in the modules? You're going to find the functions. When you look at the code, you will find the functions. F1 to F20, let's say 20 functions here, 30 functions in M2, 20 functions in M3, and let's say 30 functions in M4. What happens in monolithic applications? Think from the code perspective. All the modules are packaged together. Mono means single. Lithic means big. Single big unit. When all the modules are packaged together, what does it mean? Let's say if I'm writing M1, I'm writing a function F1. I'm calling other functions, other modules. There is a huge dependency across the modules. And because of that, the entire code is packaged together. You get one jar file, one war file, or what ER file. Let's say consider if this code is Java, you get one jar file where you're gonna in that jar file you will have every code packaged together, all the modules packaged together, and there's a huge dependency. The functions across the modules are being called anywhere and everywhere. If I'm writing a function in M1, it's calling functions of other modules. M1 is calling M2, M3, M4, M3 is calling M1, M2, M4. Huge dependency packaged together. That's called monolithic. What is the problem, friends? Even for the smallest change, let's think from a development perspective, even for the smallest change in one of the modules, in one of the functions, you need to deploy everything together. Yes or no? Think about it. Because there's a huge dependency. M1 is dependent on M2, M3, M4. If I am doing a bug fix, if a developer is doing a bug fix in F1, one of the functions in M1, if you want that code to be present in production, you need to build the entire code base. You cannot just deploy M1, entire code base. That's one of the things. That's why whenever you have monolithic applications, frequent deployments is not possible. Quarterly release, 6-month once release we do. Because such a big code, we cannot just push one code, right? It doesn't work like that. What are the other disadvantages? The major one, okay? Because of dependency, if the issue is with one of the functions, let's say F1 is not working, let's say M1 is not working because of F1. One function issue with one of the functions can bring the entire application down. This is we don't understand this, right? Because this is the truth. Because there is a huge dependency. If there is a bug in F1 for any region, if F1 has a bug, one of the functions, one of the modules has a problem, it's failing. It's going to impact other modules which is being called. Whoever is calling this function of this module, that module get impacted. Eventually, everything would get impacted. So even for the smallest issue can bring the entire application down. Very problematic, right? So how to solve this problem? So first of all, do we realize it's a problem, guys, and we need to fix this kind of a problem? First of all, do we realize this? That's very important. The question, the problem should be understood. Solution is easy. Friends, do we understand the problem? Yes or no? How to solve this problem? Simple, split it, make it independent, remove the dependency. Remove the dependency. And that's what we call it microservices. When we split M1, M2, M3, M4, make it independent of each other. I'm not going to call the functions. If M1 needs to call M2, it will call through API call, not direct function call. I will expose endpoint, get call, post call. I will expose API calls. If M1 needs some information from M2, call the API and get the information. API, friends, I hope you understand. When you go to make my trip, I was giving you this example, right? When you search for the source and destination and date, you click on search. What happens, friends? A request goes to every website. How do you see? How do you think this Indigo, SpiceJet, Akash Air, all the details are coming? How it is possible? Friends, API, do you think Make My Trip owns Indigo, SpiceJet, Akash Air, and every other flight details here, flight carriers here? Do you think so? Make My Trip owns all these flight carriers? Or Make My Trip had database access of these flight carriers? How Make My Trip knows about these flight carriers? Have you thought about it ever? How it is possible, friends? How it is possible? Anybody? How it is possible? How Make My Trip gets the information about Indigo or SpiceJet, whether the seat is available or not, what is the price? How using Make My Trip I can book a flight in Indigo? API calls, friends. Yes, using API. These flight carriers, individual flight carriers, they have exposed endpoints, get call, post call. They have done that. They have exposed it. And Make My Trip has purchased those endpoints, get call. If when I do the flight search, I'm trying to get the details, right? So I'm calling the API of Indigo, get call, with source, destination. I'm trying to get the information. When I'm trying to book the ticket, I'll put the passenger details, every details, and I'll put that, and I'll do the post call to book the reservation. It's all API. How do you think when you open a Swiggy, Ola, Uber application, when you about to confirm your cab booking or anything, right? You always see that payment gateway. It routes to the payment gateway. Payment gateway is a third party. It's all about API. From Swiggy, Ola, Uber, API calls are made to the payment gateway. It prompts up, and then you make the payment and you confirm through API things. It's all about API, right? And that's what we will do here in the microservices. So Make My Trip and Indigo are two different websites. They are not together. If Make My Trip needs some information from Indigo, I will call the endpoint, API call, get call, post call. I will call the endpoint, get the details. Similarly, when I split big monolithic code into microservices, we made each module independent. We exposed endpoint for each modules so that they can work independently. And if M1 needs some information from M2, I'll call the API, get the information done. M1 will call M3 API, get the information done. Not calling the functions and making it independent. So what is the benefit, friends? If F1 has issue, do you think it will impact M2, M3, M4 in the microservice-based architecture, friends? In the microservice architecture, if F1 has issue, do you think it's going to impact M2, M3, M4? Why it would impact? If Indigo has an issue, do you think Make My Trip would get impacted? No way. So that is the power of microservices. We split this big monolithic code into microservices to make my application highly available. That's one of the important things. from a reliability perspective, we are here to talk about reliability. What is reliability? High availability, robustness. Even if failure will happen, it will come, it will be reliable, it will be operational. So this application architecture will make my application reliable, will make my application highly available. It is not going to give me a downtime if F1 has some issue. It will not work. One of the features will not work. That's fine. But it's not going to give the entire feature will not work. It's not, it will never happen. The power of microservices. Because we are independent here. Able to understand, friends, high level? Everybody on the same page? Everybody on the same page, friends? That's the power of microservices. And now the question is, where do we deploy microservices? Where should we deploy? That's the next question. And that is where the containers come. That is where the containers come. We deploy microservices on the containers. First of all, what is containers? We need to understand this. What is containers? So when the software development deployment started, friends, it's all started with physical server. Big machine, physical server. And we were deploying tiny little application. Because we didn't know about VMs back then, but no concept of virtual machine back then. We didn't know. We were wasting a lot of resources. Then came the virtualization phase. We installed a virtualization software like Hypervisor, VirtualBox, Hyper-V, VMware software, and we virtualized the physical server and we could create VMs, virtual machines. If anybody knows your cloud, if you go to AWS, go to EC2, you create an instance that VM. AWS has done the virtualization for you. That is why you're able to create VMs, virtual machines, and we deploy monolithic application on these VMs. But again, we realize that VMs are not optimally used. So what we have done, friends, we used one VM and we could create multiple containers in this one VM itself. In one VM, we could create multiple containers and we could deploy multiple microservices on those containers just to make sure the VMs are fully utilized. We will talk about containers in detail, but at the high level, did we understand, friends, what is the concept of virtualization and containerization? It's all about cost optimization. Through the efficient utilization of the resource, we do the cost optimization. Know that for now that on the containers, we deploy microservices and we could create multiple containers in one VM itself. We can create as many containers till its full capacity of a VM. We want to utilize the resources to its full capacity. What is the point of not using the resources? We are wasting resources, which is leading to the cost. If we could optimize the resource utilization, we could save a lot of dollars. Companies, those who have containerized the application using Docker or Kubernetes, they have saved 50% up to 90% of the cost because they're able to utilize the resources better in the containerization. And we will talk about Docker and Kubernetes. I'll talk about the course, for friends, and you'll understand that why we are talking about these things, because our course is based on all these four things.
This
And then
conference
we have
will
the
now
cloud.
be
We all
recorded.
know data
Madhu,
center
I
very
just need a
costly.
small
Not
request from
everybody
you
can
that
afford to have
in
a data
just in
center.
case if I forget regular expressions at the end, you just remind me. Okay.
You need to purchase the land, construct the building, purchase the hardware, have people to maintain. Very costly affair. We
Okay.
can use a cloud service
Let us
provider
discuss.
like AWS, Azure, and GCP, and we can get started at the earliest. We can deploy the application, be up and running. So these four things are very important, friends. Do we realize now? those who have no idea about four things, I hope you had good learning for now, friends. Now, do you understand these four things quite well? I hope. Please yes or no in the chat. We'll proceed with the course content now. Good. Good to know. As promised, I have met my point. You'll have some learning, right? Good. Now let's talk about the course, friends. So in the course which I'm coming up, I'm talking about these four things because these four things from reliability perspective, from performance engineering perspective, from the SRE perspective, from the cloud engineer perspective, we're going to talk about in the course. That's why I was explaining these things in detail. Just a trailer, okay? Very small trainer. We're going to talk about 50 hours on this four things, okay? Let's talk about the course, friend. I'm going to directly take you to the link. This is the link, friends. The course which I have coming up with Isa, and I'm going to share this link with all of you first. I have pasted the link in the chat, friends. You can copy that, use that later. Now, please listen to me. In this course, we are talking about the four things. We will start with cloud. The first thing first. We'll start with cloud because that's the infrastructure. Every topic is a hands-on. Every topic will be from scratch. I will show things, not like how explaining. I will explain things, but you will see me doing stuff in the cloud. Everybody in this course, whoever gonna enroll, will will be working on this cloud. Everybody would be having this cloud console, and we will be creating a lot of resources. You will be using a lot of services, 20 to 25% services 20 to 25 services we're going to talk about in this. So we have a lot of services in the cloud. We'll talk about AWS, friends, in this course. But if you know one, you can easily learn Azure and GCP. That's how I have learned things. Start with one. If you don't know any cloud provider, start with AWS, which because that has the largest market share. So everybody would be having this account. I'll guide you how to create this account and how to make sure you don't incur cost. I'll make sure that. And then we'll learn hands-on. Now, I can talk about services, friends, but again, it will be boring for you because if you know it good, we'll talk about from basics, okay? Just know that we'll talk about from basics. What is cloud computation, right? What is infrastructure service, platform as service, what is software service, what are the differences? We'll talk about how do we create servers, how do we create users, how do we create storage, load balancer, auto scaling, storage services, EBS, EFS, S3. We'll talk about a lot of things, friends. So I'm not going to just name everything. It will be boring for you. Don't worry right now. Just know that we'll be talking about cloud from scratch. You'll be learning cloud, AWS here in this course. You'll be learning AWS. Now, second thing that you're going to talk about is Linux. 95% of the enterprise application is deployed in Linux. I have seen people are comfortable with Windows. They know how to navigate in Windows because it's a GUI, it's a graphical user interface. But we struggle in Linux. I want to solve that problem for everybody. I want you to get a feel of Linux as you get a feel in working with Windows. I don't want any difference. It's just a operating system. You don't know how to use it. That's all. We'll make sure that you are as comfortable in Linux as you are with Windows. That's my tagline. Get as comfortable with Linux as you are with Windows. That's the motto of this module. You need to feel comfortable. Doesn't matter. Linux, fine. Again, a lot of things will be there. I'll just do one thing, friends. I'm going to show you along with this, I'll show you the PPTs that will be covered as part of this course. Let me just show you the PPTs. I'm going to take it one of the top, one of the batches. Let's say I'm going to show you. So you're going to find all these PPTs. So all these are materials will be shared to you. When I talk about the cloud, we will talk about this PPT and it has more than 150 slides just for the reference that we don't miss anything. Okay. Everything would be dealt here with good diagrams and everything in detail about the PPTs here. And if you see, we have approximately 150 slides, 170, 150 slides we have it, right? Now, coming to the Linux part, again, for everything we have this. For Linux and shell scripting, again, we have a PPT, friends. Just for the reference, we will do everything hands-on. I'll show you commands executing, right? Now, all these things will be discussed. Directory navigations on the Linux part, and you can just go over it, okay? This course is a vast course, okay? We have segregated the live sessions and recorded sessions, okay? So there are a couple of things will be recorded sessions. For example, this Linux part, the Linux part which I'm showing you is going to be recorded session. My recorded session itself, just to best use of time, okay, will be recorded session. As I have also already mentioned here, the recorded video sessions will be provided. The cloud will be live sessions. Linux will be recorded session. My recording only. Okay, just know that my recording only. You can ask any doubt how the recording would look like. Let me show you as well. So there will be playlist will be shared with you. And this is the basic, some 3.5 hours. You don't need a lot of details. 3.5 hours of cloud Linux will be enough for you. Raj Thakur, as I told you, we'll be talking about AWS in this course. You can learn Azure by yourself. Let's focus on only one cloud. If this course takes, guys, 50 hours, okay, 40 to 50 hours, it takes approximately 2.5 months to 3 months to complete this course. We'll be meeting 3 days in a week, Tuesday, Wednesday, Thursday, same time. We'll be meeting approximately for 4.5 hours, 5 hours in a week, and it will take 2.5 months to 3 months. This course is a vast course because we take it from scratch, right? We cannot put Azure, but if you have any questions, Raj Thakur, in Azure or GCP, you can ask. Hands-on. Yes, so that's an everything is hands-on. These are hands-on. These are recorded, but hands-on. This is from the recorded session. Earlier, I used to take the live sessions, but just in the course of adding more topics, making it better, this course, I have put that as the recording. This is from the live sessions, live session only. Okay, Sudarshan, know that. I'll be upfront, friends. This is going to be a recorded session, and you can ask me any question you have. All those fee and all, please contact Mr. Kumar Kikilomo. You have the number in this website. If you scroll down, you have Mr. Kumar number. Please reach out to him. He will be guiding you on the fees part and all. Okay. With me, only technical things, right? All those other part will be Kumar will be taking care. Now, coming to the course syllabus, friends. So cloud, Linux. Third thing we're going to talk about, friends, is the SRE concepts. Live sessions. I will be clear which will be the live, which will be recorded. Live sessions. What is reliability? What is fault tolerance? What is high availability? What is disaster recovery? We're going to talk about this in the SRE. We'll talk about architecture. What is monolithic microservices? We'll talk about Docker. How do we create containers? How do we deploy microservices using Docker, using container engine? We'll talk about Docker. We'll talk about Kubernetes. I'm not going to go in detail about each and everything. Again, you'll not understand as of now. So just know everything is hands-on from the scratch. Docker, everything is live sessions here. We'll talk about performance engineering in DevOps. How performance engineering fits into DevOps. What is the roles and responsibility of a performance engineering in DevOps? We'll talk about continuous shift left and shift right approach. We'll talk about continuous performance testing in DevOps. Because when we talk about DevOps, friends, when we talk about DevOps, it's all about automation, and we need to do automation. Continuous performance testing in DevOps. We'll understand this. How do we create jobs? How could we automate performance testing using in DevOps? We'll talk about that. Yes, Sudarshan, we'll talk about Docker and Kubernetes. See, Docker and Kubernetes are not related to AWS. They are separate tools, but we'll be using AWS services for Kubernetes EKS. And for Docker, we'll talk about ECS. We'll talk about AWS services only. We learn the concepts, Docker and Kubernetes, and then we'll talk about AWS services. So that's right. So continuous performance testing. How do we create Jenkins job? We'll talk about Jenkins here. How do we create Jenkins job? How could we schedule performance job in Jenkins pipeline? Because that's CI/CD pipeline. Because when we talk about automation, friends, when we talk about automation, we need to understand, because performance testing is also part of automation. How could we play an important role? How could we automate this performance testing part? In this DevOps, we'll talk about this, right? Because this 5 to 11 is an automated activity. And our job is also to make sure we have a performance job automated. When functional testing is successful, performance testing job should trigger automatically and should confirm how about my performance has been. So we'll talk about Jenkins, friends. With Jenkins plus Jmeter here. So it is not a Jmeter course. I will talk about integration, friends. Understand the difference. It's not a Jmeter course. I'll talk about integration here. You should have Jmeter knowledge as a performance tester. This course doesn't talk about Jmeter. This course talks about the integration part. And how could we play an important role? How could we participate in the pipeline? We'll talk about that. Are we on the same page, friends? What this course will talk about? No confusion, right? Should not be any confusion. We are not talking about Jmeter here. I'm trying to make it clear. We'll not talk about Jmeter, but if you have any questions, I can answer you because I am a proficient with Jmeter. But in this course, we'll not talk about Jmeter. Right? We'll talk about this integration, performance engineering in DevOps, right? And then we'll talk about gaining resilience and reliability on AWS. How S3 plays an important role, how databases, RDS, DynamoDB plays an important role. Right? We'll talk about reliability in AWS. Along with that, everything is live sessions, friends. Only one recorded session as of now, Linux. We'll talk about observability. We'll talk about Linux monitoring, which will be part of recorded session. Linux monitoring, it's part of Linux. We are talking about Linux monitoring. In the shell script, I have demonstrated using the Linux monitoring. How can we use shell script to do the Linux monitoring? We'll talk about CloudWatch, live sessions, Prometheus and Grafana, Elk. Everything is live session here except Linux monitoring, because that recorded session covers Linux monitoring. Everything is live session here. We'll talk about Prometheus, Grafana, and Elk. Now, we will talk about, friends, Java performance engineering. Java performance engineering in this course, because we're talking about cloud performance engineering. We are already taken care, but performance engineering is not complete without application performance engineering. So we'll talk about Java here. How do we tune Java applications? What is garbage collection, heap dump, thread dump, GC log? We'll talk about this. And this is going to be recorded session, friends. My recorded session itself. I'll show you the playlist, friends. The playlist is here. Let me just show you the playlist of Java performance engineering. Here is the playlist. This is the playlist you'll be given access to. 10 hours of content, 10 to 11 hours of content here will be shared with you. And we'll talk about what is performance engineering, JVM architecture, memory layout, GC algorithms, heap dump, thread dump analysis, GC log analysis. We'll talk about this in this course. So you'll be given a recorded session of this. Yes, we'll be using the same AWS services. Yes, CloudWatch is from AWS, friends. If you look at the CloudWatch is the monitoring solution of AWS. We'll talk about this in this course, CloudWatch. How CloudWatch helps to monitor things in AWS. Along with Prometheus Grafana and Elk Stack, we'll talk about other open source tools also, right? Understand Prometheus and Grafana and Elk Stack. We'll talk about that as well. Then we'll talk about, friends, eliminating toil using Terraform and Ansible. Using CI/CD pipeline, using Terraform and Ansible, we'll talk about that. So this is the course, friends. And as part of recorded session, you'll be given a core Java recorded session and Python recorded sessions. So this is a complete course of SRE, okay, where we have giving you 100 hours of content, where we are covering 50 hours of live sessions. Not 100, it would be 80 approximately. Where the 50 hours is live sessions, and up to you, right? Python, if you want to learn Python scripting, you have the recorded session. If you want to learn core Java, you have the recorded session. We are not going to cover core Java and Python scripting in the course. It will be part of the recorded session. Right, so this is the course, friends. I'm coming up with Isha, and today is the demo session. We're going to start with tomorrow, day one. We are not going to take any break. Tomorrow is the day one. Feel free to attend day one and understand the course, how we are going to go about learning things. Okay. Are we on the same page, all of you? Anybody, any questions? Please go ahead. You can unmute yourself and ask any question if you have about the course. So to sum it up, friends, we are covering cloud, AWS here, Linux, plus shell scripting. We're talking about Docker, Kubernetes, Jenkins, CI/CD pipeline, continuous performance testing in DevOps, we're talking about observability using Prometheus Grafana. I'll just put observability. Using CloudWatch, shell scripting, Prometheus Grafana, and Elk. Elk stands for Elasticsearch, Logsearch, and Kibana. We are going to talk about automation using Terraform and Ansible. We'll talk about reliability, SRE concepts, fault tolerance, incident management, everything, SLOs, SLIs, SLAs, incident management. How do we do those things? We'll talk about that, and gaining resilience in AWS. Using AWS services. Correct. Correct, Vignesh. Azure, see, any cloud is on the similar lines. See, they are just the provider. The use case doesn't change, Vignesh. If you're using AWS, why we use cloud? Because we want to use the server. We want to get the storage. The entire Netflix is in AWS. And what they're using? The storage. The entire content that you watch in Netflix is stored in S3. S3 is one of the service in AWS. The entire Netflix content that you watch is stored in S3. S3 is a storage service, simple storage service. Similarly, there is a storage service in Azure called Blob Storage. Similarly, similar to this, we have a Blob Storage. Similar to this, there is a service in GCP called Cloud Storage. Every cloud is similar on similar lines because the use case doesn't change. Name changes, UI changes, the concepts remain the same. Okay, friends, this is what we're going to talk about in this course, friends. To sum it up, we'll talk about one of the important things, Java performance engineering. These are all the cloud performance engineering. This is the Java performance engineering. This makes the course complete, friends. So we are going to talk about this in this course. Jenkins and CI/CD pipeline is not a different things. We're going to talk about CI/CD pipeline using Jenkins only. Jenkins is the CI tool. Right? We'll talk about this. So these are the topics, friends, about the course. I hope everybody understood about the course and everybody got to learn something today. That was my intention. All good? Everybody learned something today? Good, friends. Good to that's what my intention. Good. Any questions, friends? If not, we are done. We will meet tomorrow and discuss. We'll directly friends term with cloud, right? Coming to the material, friends, you have a lot of materials. Okay, I wanted to show you. Just know that from tomorrow, friends, we are going to talk about cloud. We'll directly start the topic without waiting any longer. We can talk about this. Coming to the course, the material that you're going to get for everything, you have this PPTs that you can refer. Along with this, you have a lot of commands that I'm going to share on daily basis. Okay. Uh, you have SREs module where we talk about eliminating toil, monitoring features, right? Different Grafana installation. Everything is documented here that I'm going to share with you. Right? The sessions will be recorded and it will be shared like this, like the one that we're recording right now. Every session will be recorded and you'll be getting a session like this, friends. Like in the YouTube playlist, you'll be getting like this. So this is one of the batches that I have taken in May last year. And this is the topics that we have covered on daily basis and this is what you're gonna get. One of the batches going on weekends, evening, that's running actually. Right? This is the weekdays batch. 3 days in a week, Tuesday, Wednesday, Thursday, 8:30 to 10 p.m. is what we're gonna cover. Correct, Vignesh. All are similar lines. Only the difference is that you are not going to get two things in the cloud PE course. What you don't get is Java, core Java, and Python. This is what you don't get. This is not available in the cloud PE course. Not available. So this is available as in the SRE course because this is required for the SRE. Not available, not part of cloud PE course. Cloud performance engineering and DevOps course. Okay, just know that the difference. This is the only difference in these two courses, Cloud P plus SRE course. Anya Uma gift weekly trainings free or paid. You need to, it's going to be payable, right? You need to have some commitment from your end, right? That's important. So it's going to be chargeable, and you can talk about to Mr. Kumar. Okay, we need serious candidates here, right? So it's going to be chargeable to answer your question. And please reach out to Mr. Kumar for sources details. What are the charges and all those things? I don't deal in those things. I take care of technical. Anything technical you can ask me. And for other details, please to get enrollment and all, please reach out to Mr. Kumar. The number is in the website link. I'm gonna again share this link, friends. I'm going to again share this link, and you have the number, Mr. Kumar number here at the end. Please reach out to him for the enrollment. If you're already in the WhatsApp group, you'll be getting notifications, right? Uh, Feel free to attend a couple of sessions that are going to be free for this week. At least till tomorrow, it will be free. Just take a call. And there are demo sessions available also in this particular link. Last batch recorded sessions. It's available here. Okay, you can also go over this. Okay, friends. So that's all I wanted to cover today, friends. I hope everybody understood about the course, what value is going to bring to your career, and you can take a call accordingly, right? So that's all from my side, friends. Thank you so much, everybody. If you have any question, feel free to ask. Thank you so much. Thank you, friends. Have a great day and a good night. Thank you so much.
Option 1. Option 2.
Meow.
Option 3.
Meow.
Option 1.
Meow.
Option 2.
Meow.
Option 3. Option 1.
Meow.
Option 2.
Meow.
Option 3. Option 1. Option 2. Option 3. Option 1.
Meow.
Option 2. Option 3. Option 1.
Meow.
Option 2. Option 3.
Meow.
Option 1. Option 2. Option 3.
Meow.
Option 1.
Meow.
Option 2.
Meow.
Option 3. Option 1.
Meow.
Option 2. Option 3.
Meow.
Option 1. Option 2. Option 3.
Meow.